Let me show you some capture examples. Here, I've set up a couple of local variables in my calling scope, x and y, and put some values into them. Then I have the same kind of for eaching that we've been doing all along, and my lambda, the third parameter to that for each call, this time is capturing x and y in the square brackets. So you see using x here and using y here. And all I'm going to do is print out only elements of the vector that are, in this case x is 3, so 3 or more, and simultaneously they are 7 or less. So we'd expect to see 3, 4, 5, 6, 7. Then I'm going to print the vector out just to prove that it hasn't been changed. So this app is still running. I'm going to run down to here and show you the output. You see 3, 4, 5, 6, 7 down here, and the vector itself still unchanged. This lambda captured this x and y from local scope. It's not really running here when they are in scope. It's using its own copies that are in the member variables of the anonymous function object. It just feels exactly like still these being in scope and still using them. I can do the same thing. I've just changed the values of x and y to make it obvious, capturing, quote, everything, unquote. Now it really doesn't capture everything. There's an awful lot of things that are in scope at this point in this application. We've got our vector v, we've got our second vector v2, we've got a vector of doubles called dv, and a whole pile of other things that I've sort of created as I went along throughout the various demos of this module. Only x and y will actually be captured by that equals sign. This is the exact same code, but with 2 and 9 instead of 3 and 7. So if we run down to here, you can see that we're printing out 2 through 9 and that the vector is still unchanged. What if I wanted to change x or y or elements of the vector that I'm iterating over? A couple things going on here. First of all, I'm capturing, quote, the whole stack again by value. So that's x and y because they're used here. But I've put the word mutable in the declaration of the lambda. That's what enables these lines to compile. Normally, x and y would be const member variables of the lambda's anonymous function object, but because of the word mutable, I'm allowed to change their values. However, because I'm capturing them by value, as you see here, when I print it out here, x and y, you'll see that in fact they are still unchanged. So I changed them both a lot as we went through, old being the element of the vector. So the first time through, old's going to be 0, and x will become y, which is 1, and y will become 0. But as we continue to go through, and the last time we go through, old will be 9, the last element of the vector, and y would become 9, and x would be 8 from the time before. However, when I run this, you'll see that in fact x and y are still going to print out as 1 and 1, because the lambda is only changing its own local copies of x and y. I've also changed the parameter to the lambda from an integer, which it's been in all the other examples, to an integer reference. And that means that here, when I change r, I'm actually changing the real values back in that vector v. So we're going to print out that vector v so that you can see that that's what's happened. So run down to here, take a look at the output. The vector has actually doubled, but x and y are still 1 and 1. If I want to capture x and y by reference, so here I'm going to clear my vector, that's a vector method that I've mentioned before without showing, and then push 0 through 9 back onto it again. So we've gone from the 0, 2, 4, 6 back to the 0, 1, 2. This is the exact same body of the lambda, but the capture clause is different. I'm capturing x and y by reference. That way, as we go through, old taking on the value of the value we're on the vector, x being y being old, we'll end up with 8 and 9, as well as continuing to double the elements of the vector, which we're taking by reference, so we're really doubling the real vector elements. So when we come here, you see that x and y are now 8 and 9, as well as doubling the vector. It's totally up to you as the C++ developer what you capture by value, what you capture by reference, whether you take your parameters by value as we're doing here when we're just printing them out, or by reference as we're doing here when we actually want to change them. Just so that you can see one that takes the quote whole stack by reference, this is another way to fill the vector. I clear it, and then I use a standard function called generate_n. Generate_n takes a particular transformation function like backinserter, which we were using in transform, and says do it, in this case, 10 times. And what is it that I'm going to do? Well, I'm using a lambda. And I'm simply working with this I and incrementing it. And because I've captured that I by reference, when I'm incrementing it, I'm incrementing the real I. So when we come out the other end, for example, you'll see that I ends up being 10, having gone through 0 through 9. So if I run down to here, there is my vector one more time, initialized a slightly different way, and there is my I that got incremented up to 10 after running through the backinserter 10 times. Now you've seen how C++ takes such tremendously fine-grained control over the capture of the lambda. This really sets it apart from some other languages that don't give you this level of control.